Okay, we're still in the topic of quantifiers, but now we look at on quantified statement with two variables. Okay, for the quantified statement with two quantifiers, we call it as, we use multiple quantifiers for that kind of statement. Okay, when a statement involves both existential and universal quantifiers, the order in which the quantifiers are written need to be placed carefully. So let's say we have open statement with two variables, p, x, y, okay, where the open statement is equal to x plus y equal to 6. Okay, when we have existential of x and existential of y, pxy, so that statement is, we call it as logically equivalent to the there exists y, there exists x, pxy, because they have the same existential quantifier for both x and y. Okay, so for this kind of statement pxy, we can call it as, we can read the statement as there exists an integer x and y, because both x and y use existential quantifiers, okay, such that x plus y equal to 6. Or we can read it as there exists an integer y and x such that x plus y equal to 6. Okay, so these two statements are equivalent statements. So that's why it can be represented by logically equivalent. Okay, besides that, the statement also similar to this kind of writing, where we just write down only the exists x, y, pxy, or there exists y, x, because these two statements are logically equivalent. Okay, now we look at on when we're dealing with universal quantifiers for both x and y. So let's say we have for all x, for all y, pxy, it is logically equivalent to for all y, for all x, pxy. Okay, how to read that kind of statement? Right, so we can read it as for any integers x and y such that x plus y is equal to 6, or for any integers y and x, because y comes first, okay, such that x plus y equal to 6. Okay, we are able to determine the truth values of each of these statements. Okay, look at this example. In order to determine the truth value for this example, okay, once we select x, let's say we select a value of x, only y equal to 6 minus x does exist. Right? We cannot select any value of y. Okay. Hence, the statement is false because it does not satisfy for all y. Okay, let's say we have more than two quantifiers. So the similar result also be follows the statement involving 3 or more such quantifiers. So in this example, in these notes, we have a mix of quantifiers. Okay, for example, we have the exists x for all y, pxy. For all y, there exists x, pxy. Or for all x, there exists y, pxy. Or there exists y for all x, pxy. So the way we read the quantifiers is from left to right. So hopefully you can try, you can check on this, okay, to have different kind of mixed quantifiers. So you can use the same open statement pxy that we have before, and you try to write the sentence for each of these mixed quantifiers, and hopefully you can determine the true value of each of these statement.